Hi and Assalamualaikum. Today we are going to present to you our group project. So we decided to choose logical connectives as our topic. My members and I will explain to you about what is the logical connectives and show you some examples related to this topic. So, what is logical connectives? Logical connectives, also called a logical apparatus, is a symbol or word used to connect two or more sentences in a grammatically valid way, such that the sense of the compound sentence produced depends only on the original sentences. There are several logical connectives. Each logical connectives have their own symbols and statement. But the first one is conjunction and the symbol. The statement is and. The next one is disjunction, the symbols. And the statement is or. The next one is negation. There are two symbols for these logical connectives. And the statement is not. For conditional or implication, the symbols and the statement is if, then. For the last one is biconditional and the symbols. The statement is if and only if. For conditional or implication, which is the implication of Q by P, the proposition P is called the hypothesis and the proposition Q is called the conclusion. Alternatively, we can also say P implies Q, or P is sufficient for Q, P is sufficient condition for Q, Q is necessary for P, Q is necessary condition for P, or if P then Q.
Next, let's take a look at truth table of logical connective. First, not P, and the definition is the negation of statement P. Second, P and Q. If P is true and Q is true, then P and Q is true. Otherwise, P and Q is false. Next, P or Q. If P is true or Q is true or both are true, then P or Q is true. Otherwise, P or Q is false. Then, P implies Q. If P is true, then Q is false, then P implies Q is false, otherwise P implies Q is true. And the last one is P biconditional Q. The definition is if P and Q give the same truth value, then P biconditional Q is true. Otherwise, P biconditional Q is false. There are three types of proposition. First, tautology. Tautology happens when if all truth values are truth. Second, contradiction. Contradiction happens if all truth values are false. And lastly, contingency. Contingency is if the truth values contain both true and false.
We are going to show you some examples. For the first example is that P, Q, R, and S are the proposition as follows. P, Amalia is cleaning the room. Q, her mother will buy her a new book. R, she is reading a book. And S, Amalia is sad. For the first statement is if Amalia is cleaning the room or she is reading a book, then her mother will buy her a new book. And the symbolic form is in bracket P or R implies to Q. And the second statement is if her mother will buy her a new book, then she is not sad. The symbolic form is Q implies not S. And the third one, Amalia is cleaning the room if and only if her mother will buy her a new book. The symbolic form is P biconditional Q. And the last statement for this example is Amalia is not cleaning the room and she is reading a book. The symbolic form is not P and R.
Example 2. Let P, Q, R, S, and T are the proposition as follows. P. Alia is doing revision for her upcoming examination. Q. Alia is joining a group discussion with her friends. R. Alia is getting an excellent result. S. Alia's parent will proud of her. And T. Alia's parent will buy her a MacBook as a present. Statement 1. If Alia is doing revision for her upcoming examination and joining a group discussion with her friends, then she will get an excellent result. And the symbolic form is in bracket P and Q implies R. Statement 2. If Alia is not getting an excellent result, then her parent will not proud of her. The symbolic form is not R implies not S. Statement 3. If Alia is getting an excellent result, then her parent will proud of her and will buy her a MacBook as a present. Symbolic form is R implies in bracket S and T. Last statement, Alia's parent will buy her a MacBook as a present if and only if she is getting an excellent result. And the symbolic form is T biconditional R.
Next, we will see example 3. So here, we have to construct the truth table for the equation negation of in bracket P and negation of Q biconditional with P to determine whether it is tautology, contradiction or contingency. The first and second column is for our main proposition, which is P and Q. Then we put our symbol, which is negation of Q, P and negation of Q, negation for the P and negation of Q. And the last column is for our original equation. As we learned from the previous slide about the definition of the truth table, we can determine whether the equation is true or false. So here, for the example 3, we have true, false, false, and false. Since all the truth value contain both true and false, the statement is contingency. Next, let's see example 4. So here, we have to show that what is the result for P and negation of Q implies negation of Q. Same with the previous slide, we have to put all of the information into the truth table to determine either the symbol is true or false. When the value false implies to another value that shows false, we will get the true value. And here, for this question, at the last column, we got all the truth value is true. So, we can conclude that the equation is tautology. And lastly, let's move on to the last example. Here, we have negation of P and negation of Q implies 2. P implies negation of Q. So in the table, we put P, Q, negation of P, negation of Q, and the hypothesis and the conclusion. And last column, we put the original question. For the implication, we notice that when the hypothesis is true, but the conclusion is false, we got truth value false. So for this question, we got all the truth value is false. And with that, we know that the statement is contradiction.
The conclusion of this topic. So, we use symbols to stand for the relationship between statements in order to indicate the form of an argument. These relationships are made by possible logical connectives such as conjunction and disjunction or negation, not, conditional, if, then. Connectives are used in compound statement, which is one of each is composed of at least two simple statements.